Hello, this is Britt Caswell. I am a math teacher and welcome to my channel. In this channel I will be describing for you guys different methods of factoring and how to factor, and then I will walk you through all of the ways in which we use factoring to help us with quadratics. This first video is designed to walk you through a graphic organizer that I designed called the Factoring Big Picture, and instruct you on how to use this graphic organizer as we move through factoring. The first thing I'd like to point out to you is the standard form, which is written here across the top of the big picture. If ever we go to factor, we have to have our expression written in this standard form, where the exponents are counting down. The next key feature is down the left-hand side of the page and the right-hand side of the page, where we have listed off all of our perfect square and perfect cube values. Factoring is very reliant on being able to recognize patterns, and these are some of the key values that you're going to look for as you determine what method you're going to factor with. When we do start factoring, you always want to start with the process of finding the greatest common factor. Okay, I have written the definition in here. We'll get into that definition in my next video, as well as an example. I'm going to point out here a reminder, a greatest common factor is not always a number. Sometimes you have to factor out a variable as well. Once you've determined what your greatest common factor is, then you want to think about how many terms there are. So if you have a polynomial with 2 terms, you're going to look at this left-hand column of boxes. 3 terms, you'll look at this middle box. And 4 terms, you'll look at this far box. So that is a guide in terms of starting to figure out which of our methodologies we'll be using. On the 2 terms boxes, you will see that I have labeled which term is missing in order to use this value. So where it's referencing the B term and the C term, you want to go back to your standard form. So the B term is the value in front of x, and the C term is your constant when the equation is set equal to 0. So depending on which of those is missing, that'll tell you what kind of factoring to do when you only have 2 terms. If your C term is missing, you're going to be using this right here, which is just factoring out your greatest common factor. Make sure that that greatest common factor includes x in it. If your B term is missing and you have subtraction, that's where you want to start looking to see if you have a difference of squares. A lot of times for difference of squares, you'll need to factor out a greatest common factor, and then a difference of squares becomes available for you to see. So sometimes that can be a little bit tricky if you haven't factored out your GCF first. The next one is the sum of squares. Many people consider the sum of squares as not factorable. In my case it is. One thing I noticed is a small typo. These things should say an I next to them, but for some reason it's not loading. But if you have a plus between the 2 terms, you get a sum of squares. We factor it in the same way, but it creates an imaginary answer. So after the b's, you'll have the letter I, and that is not factorable in Algebra 1. However, it's useful later on to know that the sum of squares exists, so I did put it on the graphic organizer. The next thing is the sum of cubes. While with factoring we are mostly going to focus on quadratics, sometimes we will run into cubic functions. So it's nice to have the sum of cubes and the difference of cubes formulas because they're so easy to help you to factor. Another thing I'd like to point out on the bottom right-hand corner is the perfect square trinomial formula. This is when you have some kind of binomial being multiplied times itself, it creates a certain trinomial. So if you can recognize those patterns, it makes it really easy to either FOIL it out without having to worry about the box method or distribution, or it makes it really easy to factor it right away. So as you practice with those formulas, you might get more comfortable with them. Moving into 3 terms, there's 2 situations you want to consider. The first is when your a value is not equal to 1. So if there is a number that is very apparent in front of x squared. The other one is when a is equal to 1. Okay. The a is equal to 1 method I call the double bubble method. We'll go through all the details on that. Here are the steps. When a is not 1, I usually teach using the slip and slide method, which I find to be a little more useful. Just recognize with the slip and slide method, if you don't factor out the GCF first, you will get the wrong answer. When we are factoring with those, we have to consider what signs would normally go in the parentheses. Like you see here in my difference of squares and sum of squares, there's different signs. So I've created this box here that helps you to determine the signs, but I also, in my teaching methodology, will teach you in a way where you don't have to memorize this. Another method of factoring is by splitting it into 4 terms instead of 3 terms. It's a method called factoring by grouping, so I've also included these steps on here. My usual go-to is the slip and slide method, but factoring by grouping is the more traditional factoring method, and I will include resources for that in case you have parents watching that may not know how to do it. But that's it. There's our graphic organizer. So throughout my various lessons that I'm doing, I will reference back to this. And I also have this thing filled out in PDF form for you guys to copy out without having to look at a video. Until next time.